In this video, we're going to come up with a formula for how to find the area between two curves, like this region in orange. So to do that, I want to remind you of something you learned back in Calculus 1. If you're trying to find the area under a curve from x equals a to x equals b, then all you need to do is integrate the function from a to b. Okay? So you probably learned a lot about how we find the area under a curve. Maybe you learned about dividing it up into rectangles, adding up the areas of those rectangles, turning that into a limit, turning that into an integral. So I'm not going to go into too much detail there because those are things you've already learned. But we're going to build on that. So if we know how to find this area in blue, that's the area under our curve f, we could also find the area under our second curve, g. So if this graph in red is g, we could use the integral of g to find the area under g. So what if I wanted to talk about a and b and use that to come up with this guy, c, which is the area between those two curves? Essentially, all I would need to do is take this full area a and then subtract this area b. And then I would be left with this guy here in orange, which is c. So that's the basis of how we come up with this formula here. If I want to find the area between two curves, then I'm going to take the area A, that's this guy, minus the area B. And one of the facts we learned about integrals back in Calculus 1 is that if you subtract two integrals with the same limits, then you can just subtract their integrands, in other words, the things you're integrating. Okay, so the important takeaway from all this is that if you want to find the area between two curves, then all you need to do is integrate the difference of those two curves, the top one minus the bottom one, and you want to integrate that from A up to B. Okay, now a couple different ways we could talk about this. If you're thinking about how to find the area of a rectangle, that's based on height times width. Okay, so if you were thinking about our drawing before, if we broke this up into little rectangles, the height of each of those rectangles would be the curve on top minus the curve on bottom. So that's f of x minus g of x. So there's my height element. And then the width of each of those rectangles is just a small delta x. So if you could imagine getting a little sliver of that area, it would be height times a little sliver of width. Well, if we added up all of those little slivers using an integral, this is how we would come up with that formula. So if you're looking for the one fact you need to take away from all of this, this is it. If we have two functions f and g, and importantly, we know which one is on top. So we're going to refer to f as the function that is higher than the other one. Then the area bounded by the two functions and the boundaries, so x equals a and x equals b, can be found using this formula. The integral from a to b of f of x minus g of x dx.